My name is Ray. I work at Square, and thank you all for coming to the first full dress rehearsal of this talk. I'm going to discuss, like it said on the title slide, doing navigation and dependency injection in Compose, a topic about which I knew nothing before I volunteered to speak about it, and now I know a little bit more. I offered to do this because when I started looking into it, finally catching up to Compose, shamefully late, I saw a couple of ongoing conversations that nobody seemed to have a consistent answer to, which was, how can I have all these wonderful composable functions and also get dependency injection to work? Can I use that state management outside of my view code, someplace that I can actually test it and keep my concerns decoupled? And why is it so painful to navigate? Surely we should have solved this by now. If I had known at the time that I pitched the talk what I know now, this is probably what I would have called it instead, because this is going to be in large part a talk about Molecule, but I promise it's not just a rehash of Molecule. There's a bit of extra flavor added. So, to frame the conversation, we're going to pretend to be doing a SaaS app, and by SaaS, of course, we mean, oh, come on, slides, Schmooze as a service, where Shmoo is something that you probably don't know about, but you should. You should look it up. It's part of your cultural heritage, especially if you're from this country. They're delicious. And what we're going to do is try to lay out an architecture to get our cloud-based Shmoo registry service at shmoo.com and create a pipeline to turn that into some kind of a UI model that we can hand to a composable Shmoo function, because we're good Compose developers and we always hoist out our state. So the bottom part of the stack is just what it should always be. It's probably some kind of RPC REST service using protocol buffers defined and compiled with wire. We'll probably use retrofit to put a service on top of that to get everything out. We'll use Room or SQLDelight to give ourselves a data access object, or preferably a repo. We want to wrap the whole thing up in Dagger, and lately probably Anvil, because there's just too much typing involved with Dagger, so that we can actually inject this whole mess. So far, so good. But then there's this kind of last mile between Dagger land and Vue land that nobody seems to be able to give a consistent answer on what's the right way to tackle this now that Compose has made our lives so much better. And in particular, and this is the space that I want to talk about, the hole I want to fill, bearing in mind that everything on the left side of the dashed line here is view space, which is liable to be destroyed behind our backs at any moment if we actually are dealing with configuration change, which you can get pretty far opting out of that. I know payment apps that have gone that way for years. But sooner or later, config change will catch up to you, especially in this world of foldable tablets and dual screen devices. I thought we were done with it, but we're not. So you might as well face it now. If you look at the Google recommendations on how to do this kind of thing, they'll trot out the Jetpack stuff, which is good, but was all written before Compose, and I don't think I'm the only person who thinks that the marriage between them is a little bit awkward. Still haven't even managed to deprecate fragments, which I'm not going to talk about. Meanwhile, in our view code, we've got this beautiful API that's directly, tightly integrated with coroutine stuff that we would like to take advantage of. It gives us specific hooks into actually firing off coroutine scopes and managing state. And the basic question is, why is all of that so good and everything over in DI-friendly land not? And I'd like to describe sort of how I wish things would work, which is actually a description of how things do work for me day to day. You may have seen me give one or two talks here over the last 100 years about a library called Workflow. This is not a workflow talk, but I had to use that slide. And I would like to describe kind of the patterns that we've grown used to in our ridiculously large apps at Square that I would hope to keep using while also adopting some of the new Compose hotness. So what's a workflow? A workflow is basically the word we used for component, React-style component, when we realized that we use Dagger a lot, and Dagger had already turned component into meaning something else, and we didn't want to confuse ourselves. And when we talked about these things, we kept talking about workflows. But really, at the end of the day, a workflow is a presenter. It's just a function that's able to take some kind of properties as input, and it's able to return what we call in workflow terms a rendering, but is really a view model as output. But of course, you can't really call it a view model because that means Jetpack view model, so we'll just say model for this talk. But it's the model that you pass into your compose function that actually embodies the state you want to display. This model should be a source of UI events or whatever events, depending what you're using the model for, so that the presenter can react to an updated state when it needs to and emit a new model. And similarly, the presenter should be able to emit its own events as output to its parent presenter or to whatever context it's running in. We're used to them being DI friendly. I'm able to inject my repo into my presenter so it can get its work done. And one of the nicest things about workflow is that it does a beautiful job of managing coroutine scopes. So I can make collect calls on flows in particular and not have to think twice about when to start collecting, when to stop collecting, when things end, and when they begin. All of this is what I've come to take for granted, but it's using a library that probably nobody else in this room uses unless you work at my company. And it has an API that felt really brilliantly concise when we came up with it, but is now sort of embarrassing because it's not remember stavable and mutable state. So I've lost my speaker notes and I forget what this slide is going to turn into. I think what I wanted to discuss here was how we might turn this into something molecule-based. Oh, no, right. Finish the workflow story. I want to talk about how we actually bootstrap all of this stuff, how we hook it into your activity, how we drive your UI from it. So we've got the workflow runtime, we give it our root workflow, our root presenter, and there's this one bootstrap call, render workflow in, which turns that into a nice state flow of these model objects, very tidy. And I'm able to pass that over into my activity. I've got, using workflow, I've got my presenter as something that I can instantiate through Dagger. I've got this render workflow in call that gives me my nice state flow. And I could probably have something like this in the onCreate method of my main activity, where I take my models and I collect them as state and pass that into the shmoo composable function that we talked about. And life is pretty good if you're workflow-based, but you just have to use workflow. So what we'd rather use is this thing called Molecule, which I suspect that you have heard about by now. Molecule is a library put together by my friends at Cash App, which exposes the bottom layer of Compose, the core runtime, which is, as you're tired of hearing, completely decoupled from UI, and lets you play with that directly. And so let's explore how we could work in this pattern using Molecule. Some of this will be a reprise of previous talks, but there are subtle differences. We'll see if you pick up on them. So let's start with our model. We're going to turn that into our shmoo model. This is a pretty simple little struct. It might be loading. It has an optional eat function because you might not have loaded it yet, or you may have already eaten it. Eat is a kind of a one-way transition, and a convenience query for whether this is an eaten shmoo or one that's ready to be consumed. The input of this is going to be the ID of the shmoo that we're going to try to fetch from our repo. And this is where we want to start using a composable function, so we get all that state management benefit. But this is where we hit our first problem. We want to inject that repo. This is a function, so we follow the README from Molecule, and we wrap this up in an injectable object. So now our repo has been injected. Anything else that we need to provide an environment for this present function to do its work. Now, if we're doing this for real, probably this is a concrete implementation of a shmoo presenter interface. Maybe we even generalize it to be an entire presenter interface with generics and everything, but that's not necessary, and for the purposes of this talk, that's a lot of boilerplate, so let's kind of assume all that is read and keep everything in concrete class terms. Anyway, we've injected this thing, and now we need to actually collect from the flow. So we do the usual thing. We get a flow of shmoo data based on the ID. We collect it as state, and we're able to render our model, which is loading if we had a shmoo, and if we do have a shmoo and it hasn't been eaten yet, then we'll go ahead and provide an eat function, and like that. And then to complete the journey again, we want to figure out how to actually bootstrap Molecule. And what you have on the screen there is the one and only use of Jetpack view model in this talk and probably in my career. There are good and bad things about view model, but in terms of providing a hook to associate your injectable business world with the lifespan of a stream of activity instances across an Android task. There's really nothing more convenient and nothing better. It'll survive configuration change. It provides a coroutine scope that starts when the task starts, that tears itself down when the task ends, and you can implement all of that by hand, but why? And then finally, in our onCreate method, we can use the handy view models extension that Jetpack provides. We grab the view models that Molecule launched for us with our fancy Molecule launch method here, and we make our set content call. And so we've done it. We've changed our workflow architecture into a Molecule-based architecture, and we're pretty ready to go. Unless you want more than one presenter, or you want a tree of presenters, or something with a little bit more depth to it. Not every app needs to work at the scale that I'm going to keep talking about here. I think the Molecule developers themselves don't usually worry about this problem because it tends to be more of a single screen at a time type of situation. But my app has approaching 1,000 screens at this point, at a ridiculous depth with a couple hundred people working on them. So we needed a little bit more encapsulation than I've described here so far. So like imagine if I want to build an index detail type of app like this, where I can check which shmoo it is that I want to check out. I might change my model from just being the simple little shmoo model to a composite UI model, split screen with two slots, the submodel that describes the index and the other submodel, the one we just created that describes this particular shmoo. So to turn that into not quite code, but a diagram that has code snippets in it, we want something like this, where we've got our shmoo browser presenter. That's going to inject the repo so that it can get its hands on the index of shmoos. And it's also going to inject two children presenters, one to build the index and one to build the shmoo stuff, the thing we already wrote. So we make our first call to the present function on this thing. It fetches another flow from the repo because it collects a state on it. It's also going to maintain its selection in the usual remember mutable state thing. Starts off as -1, there's no selection yet. Calls, because its own present function calls the present function on its child, the index presenter, provides the selection, a name of list of names derived from that index, and a select function to call back when the selection changes. Gets the index model, the UI model for the index back. And there is no selection at the moment, so we don't actually do anything with our shmoo presenter yet. It's just kind of hanging out there waiting for later use. Click event comes in, somehow routed from the view system through that index model into the index presenter, who in turn turns that into a more semantic onSelect callback to the shmoo presenter, and the shmoo presenter updates its selection state. So now we actually have a selection. Compose wakes up and fires all of our presenter functions again. We update the index to reflect the selection. We finally hand the selected shmoo ID to the other presenter, which is able to have done its own injection from the shmoo repo. It makes its own collect a state call to keep up with the stream of changes that we might make to that shmoo. Provides its presenter, its model back to the parent presenter, and we replace that empty placeholder model that we had on the right side of our original split screen with one that actually has some content in it. And so now we've implemented that little back and forth that we showed. So that was cool and everything, but all we've done so far is build a bunch of structs. We haven't actually drawn anything on the screen. There's been no UI code. So let's look at how that might work. Before we got all composite, that was easy. We just had this little shmoo call because we knew that we were collecting a shmoo presenter was running and it was giving us a shmoo model. So of course the shmoo view function is what we'd invoke. But now we've updated to a shmoo browser, which just gives us this generic split screen. What are we going to do with that? How does it in particular know how to render the stuff on the left and the stuff on the right? So there's a few ways that we can approach that problem. The first one is the brain dead obvious simple one, which is to make our UI model an interface that always carries its composable content function around with it. So our split screen model would probably look something like this, where it knows that it's carrying U models of its own, and it can call content of each of them. And out in the app side, our magic line becomes a simple call to the content function on the split screen. So this is actually probably a powerful enough approach for most things. It's very simple. It's compile time enforced. Any object that I declare as being a UI model is, by God, forced to actually tell me how to display itself. We're not so much keeping that decoupling that we were talking about originally. Like in particular, if I want my my presenter modules to be pure Kotlin and not have any Android dependencies, I just blew that up. On the other hand, in practice, the concerns aren't really going to bleed together in terms of like testability and that kind of thing. I've got a nice bucket for my business logic on the presenter side. I've got a nice bucket for my view logic on the other side. And mistakes don't really tend to happen. It's also, though, very rigid. It's hard to customize. If I've got a presenter that I would like to use with different types of views and different kinds of contexts, I'm going to have to invent that myself or just do terrible things. Still, this is probably good enough to get you pretty far. But sooner or later, you're going to need some more flexibility, and that unfortunately becomes more of a runtime situation. So instead of a UI model actually serving a purpose, now it's just a marker interface. You probably don't actually need it. It's a question of taste. I know plenty of people who are happy making their base model type just any. But I like it. It kind of signals intentionality. And we're going to introduce a binding class, a simple pair tuple type of thing that takes a particular concrete type of rendering or UI model and associates it with its composable function. And then we're going to use compose locals to wrap that up into something, a service that can provide these bindings to be available in the context of a given set of compose context. And then a paired function to pull out whatever it was that we registered so that we can just call show UI on arbitrary block of thing that I know is UModel without having to think so hard about it. I'm not going to teach you all how to use composition locals. You probably know better than I do. But one interesting thing in the class at the heart of something like that is this bindings lookup method. It's pretty much what you'd expect it to be. We fish the thing out of the map based on the type of the model that we're given. We call the content function if we can find it, and otherwise we can put a placeholder, I don't know what that is, type of text. In real life, you would probably throw at this point or have a debug mode configuration where you'd throw or do the placeholder if you're making prototypes, and so on. And then when we actually apply that, it's going to look like this on the view model side. Instead of having that content function hanging off of it, we'll have an associated binding that's available to be gathered up and registered somewhere. And up where we launched our app, the magic formula becomes this call to provide UI bindings with a list of whatever bindings I've defined, and that magical show function to actually make them go. So this is nicely decoupled. It's very easy to customize with the provide local and everything. So if I have the tablet flavor and the split screen flavor and whatever else, it's pretty obvious how to plug those in. It is really prone to runtime errors, and it's if you're especially lucky at runtime errors that you don't find out until you shipped it because you forgot that espresso test. And the boilerplate quotient is just shot through the roof, and that's why you wouldn't actually use it, although we did this in workflow for like a year. I didn't get fired. It's kind of a pain, but it is kind of necessary. What we've settled on in our workflow habits, and which I think should work just as well with Compose, is kind of both of the above. So we still have our marker interface because I like marker interfaces, and we have an implementation of that looks like the original one with the hard-coded content function right there. We change our lookup function, add a line into it so that if we fail the runtime lookup, then we can do a type check to see if there's a content function that we can call directly, and only then do we bail. And the ordering of those calls is important because by doing it this way, we're able to easily create default renderings, default composables associated with a model, but still have the ability to customize them individually as we need to. Maybe I don't like the generic split container in this app, and I want to turn it into one that has different proportions, or I want to localize the left versus right, or in a different, in a smaller screen, I want to have a drawer come in rather than do the split, whatever. The model doesn't change, doesn't have to know about it, and I have a nice little place I can put the alligator clips to make that change. And then when we actually run the app, if everything is hard-coded, we're back to this single function, show my UI for me magical environment. If we have a few things that we want to customize, we can provide those handful of bindings here as we did before, and life is pretty good. And as I said, or as I should have said at the beginning of this talk, there's a lot of hand wave going on here. The patterns I'm describing, we have been shipping within workflow for a while, even with the Compose front end. In terms of doing it in a pure compose app with a molecule runtime, I finished the slides at 1 a.m. So doing this approach, usually we're doing a compile time, binding between the model and the composable. The boilerplate is something that you opt into when it could be useful to you, so it pays for itself because you get that nice flexible customization. It's pretty much the best of both worlds, and we've been working this way for quite a while now, and life's good. All right, so I did promise to talk about navigation, and actually I would argue that I've shown you the navigation already. We had our little index detail thing, and I can choose between the two things, and I can go back and forth, ta-da, navigation. It's kind of bare bones navigation. It wasn't very pretty, but that's kind of the point. In terms of modeling, we've expressed everything that we would really need to express for navigation. We have presenters have state, and a big part of that state is your app logic, how you actually wend your way through this thing. So why should that be a separate system? But if you do want to make something prettier like this, where you get your back and forth animation, where you've got your view state being stored and restored when you restore, pop things, or push pop, whatever the one that brings the thing back, that's all doable, that's all implementable, but it's entirely a view concern. It's a way that you present this model that isn't terribly different. On the modeling side, where we were showing a shmoo model on the right, we'd probably show something like a backstack model instead, which under the hood is pretty much going to be a list of shmoo models. And I don't want to minimize how much effort this view work is. It's actually kind of tricky. But with Compose, it's a lot less tricky than it used to be. There's a library that for some reason is under my name in GitHub, but was actually written by Zach Klippenstein, because Zach writes all of the things. It's Compose Backstack, which gives you a very flexible backstack style behavior, but which states emphatically that is not a navigation library, because it isn't. It's simply a little composable function that can take a list of arbitrary keys and a function to map those arbitrary keys into composables, and we'll do animation for you. It's got several beautiful built-in effects. It's very obvious how to customize it. Like the Applix demo yesterday, any property that you can set with a modifier, it's really trivial to write custom tweaks to those based on a timer. And it's not rocket science. It helps to be Zach to write this thing, but this is the function on the screen here, which I don't expect you to read, is copy-paste of the actual core function from this with the comments stripped out. The two main services it's providing is this frame controller thing that lets you customize even more how a transition is handled beyond just customizing animation. And there's also some state management given. These are not this remember savable screen state holder thing is not a call that you get from Compose for free, but it's not a terribly big call that is built into the app to ensure that when something is pushed off display, its view state is saved. Your scroller position, your partially entered text is all there, and when I pop, it's all going to come back, and I don't have to think about it from the presenter side. I just provide the list of what I want to show. So to use something like this in the UI model idiom that we're describing here, I might have something like this, where my backstack model just memoizes the arguments that will be made to the backstack. And I'm always going to call the magical show UI function to do the part where I try to build the thing. Although, a warning, this exposed a bug in the Compose backstack, and I have a PR that fixes it badly, and we're still in the middle of the conversation of how to fix it without destroying the API. So 90% chance that this particular flavor would work, but probably a week from now, there won't be any corner cases that throw an exception. Anyhow, there's another wrapper type of thing, or another kind of composite UI model that we might want to use for something like this to let us have declarative control over our back button behavior. Compose provides this great backhandler function, which takes Jetpack's really pretty decent on back press dispatcher and turns it into something that you can declare as control that you want, so that the back button, the dreaded back button, becomes just another source of events, no different than any other button click. And all this back button ripper does is takes a function to be called when the back button is pressed, make sure that it's in place before delegating to whatever content that you're wrapping, so that you get a chance to take over the back button before it might try to. If you wanted to do it the other way, you could call show UI first and then call your own back button handler to be a backup for the one that you're wrapping, but it's all pretty simple. So the way we would actually apply this, back in our Shmoo browser presenter, where originally we had a property to remember what we were showing, we're going to turn that into a backstack, by which we mean a list. It's just a list. That's how I model a backstack. So it starts off as an empty list of our Shmoo IDs, and where we were previously using for the left side of our split screen, we're building our index thing, and we're telling it the ID of what we're showing and providing it an event handler to change the individual thing that we're showing. We're going to change what we're showing into the top of the backstack, or -1 if there's nothing there yet, and our event handler is going to push something onto the backstack by using a plus operator. There's no push, there is no pop. On the right side, where we were just rendering a single Shmoo, we're now going to use associate with to create a map of Shmoo IDs to the rendered Shmoos. And we're going to use that back button wrapper so that when the back button is pressed, we can do our pop command, which is just drop last. It's not rocket science. And then finally, in our split screen model, when we generate this whole thing, we use our little backstack model to hold our backstack list and a function to fetch the rendered Shmoos out of the map that we created. And actually, I think this is the part that blows up if you're not lucky. So, of the ongoing conversations we wanted to talk about at the beginning of this talk that took less time than I expected, we've got our dependency injection with composables. We've got that state management stuff that is just so pleasant to work with. And navigation is just not really an issue. If you've got presenters and you've got presenters that you can compose in a reasonable way, ta-da, you're a navigator. There's an entire generation or two of us now who kind of came of age with web apps and then on mobile devices that have built-in back buttons because they think everything is a web app. And we all tend to think in terms of web app semantics when we write these things. But the backstack is only one navigation scenario. It's only one particular type of app logic, one bit of state. I don't think it deserves all of the attention and angst that we give it. It's doesn't need to be the backbone of your app. Different parts of your app will have different navigation strategies, and they're just more stuff that you can express with a presenter. I haven't talked about testing, and I don't feel that I especially need to because Ash and Bill did an excellent job of that yesterday. Use Turbine, look at their 2 or 3 unit test snippets, and you've got your molecule presenters, their flows, test them that way. I also haven't talked about persistence because I am lazy. But it should be very doable to take the persistence shimming that Compose relies on, Compose UI relies on. They all get provided as composition locals in Compose UI, and there's no reason that when we're invoking the molecule runtime, we can't do the same sort of setup around there, but I don't know because I didn't try. But that's pretty much it. I've kind of recapped this thing already, but just to restate and restate, an injected tree of composable presenters is a really nice way to make a tree of composable view model structs, which molecule can stream as a state flow for you, and you can hang off of a Jetpack view model to survive configuration changes, and navigation doesn't count as an actual problem. And that is actually all that I had to say. So there's actually time for questions if you have any.